So this lesson is on something called sinusoidal modeling, which basically just means we're going to be using sine and cosine functions to model real-world phenomena. So this is pretty much a word problems lesson, no new math content because we're still using our same formulas, right, and our same little equations where D is the midline, absolute value of A is the amplitude, and the period is 2 pi over the B value. We'll also a lot of times be starting from the period. So we'll have that information, and we know if we want to find the B value, we can also do 2 pi over the period. Remembering that these two formulas are very similar, so to go back and forth between the two, you basically use the same formula. So we, once again, will not be doing any phase shifts, so we're not going to have any C values on any of these problems. So moving down the page, here's our first example. This one's about tides. So the tides in a particular bay can be modeled with an equation of the form A cosine BT plus D. So they've already told me it's a cosine equation, which is nice, where T represents the number of hours since high tide and Y represents the depth of the water in the bay. The maximum depth of the water is 36 feet and the minimum is 22 feet. The high tide is hit every 12 hours. So there's my information. It actually wants me to graph it first. So it says on the axes, sketch a graph for 2 full periods. So this can happen sometimes where they ask for more than 1 period. If I look through my information, if high tide is hit every 12 hours, okay, basically my period is 12. More important information in my graph, it says that T is hours since high tide, so we're starting at high tide. So we're starting at that maximum value because this is a cosine graph. So looking here, the maximum value is 36. So maybe I set up something, I don't know, that goes up to 40 by tens. We're starting up at 36. It says we want to graph 2 periods. So first off, I'm going to start out and just put in 1 period is 12, 2 periods is 24. From here, every single graph, if you think about your pi over 2, pi, 3 pi over 2, 2 pi, we are not using those numbers anymore, but it kind of has 4 stopping points. So I put in 1, 2, 3, 4. 1, 2, 3, 4, and that's going to help me graph. So if I think about this graph, cosine starts at the maximum. It's going to be back up at the maximum at 12 and back up at the maximum at 24. Graphing the first period, in the middle it's going to be at the minimum, which is 22. So around there. Here it's going to be right on the midline, so let's calculate that. Maximum is 36. Minimum is 22. So in between those two numbers, the average is 29. So on my graph, at these two spots, I'm going to put it at about 29. So there's 1 period of the graph. Okay, and we're going to go a second period, and that's just because it's what the question requests. So here, we're going to be at 22 again, and then at these two spots, we're going to be at that 29. So this is a rough sketch. There's no graph paper, but that's basically what your graph should look like. So from here, now that we have a graph, we're going to determine the values of A, B, and D in the model. My midline, right, is the D value. My amplitude, so from that D equals 29 up to the top, 36 minus 29 is 7. Right, so A equals 7, D equals 29, we already see. So lastly, we are going to find the value of B. And we can use 2 pi divided by the period. We talked about how the period is 12. So the value of B is pi over 6. This question should say, then write the equation for this. So if I look up here, I'm using y and t as my variables. So y equals 7 cosine of pi over 6t plus 29. As I said, I'm going to do a separate lesson on calculator work, so we're not going to worry about graphing it on the calculator right now. So this is my equation. And I'm also going to skip this question down here since we're not specifically doing the calculator work right now. So I'll come back and do that one basically when we have the calculator work. So our next problem says the height of a yo-yo above the ground can be well modeled using this equation. So if you think about the yo-yo, basically they go down and up over time. It kind of, goes faster and then slows down when it gets to the bottom and so on. So you can think of it kind of as a sine or cosine curve when you're relating the height of it to time. So h represents the height of the yo-yo in feet, and t represents the time in seconds since the yo-yo was first dropped from its maximum height. So since we're starting this from the maximum, it makes sense we're using positive cosine over here. First, we're going to determine the maximum and minimum heights that the yo-yo reaches above the ground. So to do this, we first need to find the midline from our equation. So the d value we know is equal to that number added at the end, and that is the midline. So I'm actually going to write y equals 2.25 for the midline. And then the amplitude is 1.75. So the maximum from the midline up 1.75, so 2.25 plus 1.75 gives me a maximum of 4, and my h is measured in feet, so I'm going to write 4 feet. My minimum, 2.25 down 1.75, is 0.5 feet off the ground. How much time does it take for the yo-yo to return to the maximum height for the first time? So that's basically a period question, right? We're saying how long does it take to go from the maximum back up to that spot again. So we're going to use our 2 pi divided by b formula for this. Remember, b is what's in the equation, that's not the period. So 2 pi divided by pi is 2, and t is measured in seconds. And those values should make sense when you think about, average time a yo-yo takes to go up and down and how high and how low it would go. So we're going to move to our last problem. This one's about a Ferris wheel, which also, if you think about a person's position on a Ferris wheel, their vertical position also kind of follows that up and down pattern and would be modeled well with a sine or cosine curve. So a Ferris wheel is constructed such that a person gets on the wheel at its lowest point, 5 feet above the ground, and reaches its highest point at 120 feet above the ground. The amount of time it takes to complete one full rotation is equal to 8 minutes. A person's vertical position, y, can be modeled as a function of time in minutes since they boarded t, by the equation f of t equals a cosine of bt plus d. Graph the person's vertical position for one cycle and then determine the values of a, b, and d. Show the work needed to arrive at your answers. Once again, we're going to go one step further and write this equation. Okay, not just find a, b, and d. So looking here, we're going to start, and if you think about a person getting on a Ferris wheel, they don't get on at the top, they get on at the minimum. So this graph has to start at the minimum. I need this to go up to 120 feet, and I actually suggest you pause the video and try this one on your own as well as exercise 4 and come back. Probably should have said that earlier, but pause the video, see if you can get the graph, see if you can get your equation. Okay, so now that you're back, hopefully you picked a decent scale. I used 10 feet in this direction. So 10, 20, 30, 40, 50, 100, and 120 just basically fit it on. So something around there should work well. In the other direction, I only need to go out to 8 because we're just graphing one cycle of the graph. So I found that 2 spaces for 1 minute worked the best. So I'm just going to label that out. So we talked about how if you're getting on a Ferris wheel, you get on at the minimum. So that's the first point I'm going to graph at time equals 0. So let me just get a different color. So we are starting at 5 feet above the ground. and we're finishing there because that's one period. This is a negative cosine curve we're going to see once we graph it. So in the middle at t equals 4, I should be at the maximum, which is 120. In between there at 2, I should be at the midline, so let's calculate that. The midline is the average of the maximum and then the minimum, so when I divide this out, this is my value for D. I get that my midline is 62.5. So at this 2 value in between the minimum and the maximum, I'm going to go up to about 62.5, and I'm going to do the same thing at 6. And then draw on the graph, okay, which I just erased. So I'll try it again. My hand hit something funky. Okay. So from here we can start to find the other qualities. I'll find the amplitude next. Okay. So here is my midline at y equals 62.5. To go up to that 120, so I'm going to do 120 minus 62.5, my maximum minus my midline, and that's going to give me an amplitude of 57.5. Lastly, we're going to work with the period to find the b value. So b is going to equal 2 pi divided by the period, 2 pi divided by 8, which is pi over 4. So now I'm ready to write my equation. I'm going to start out with f of t. My a value is 57.5, but this is negative cosine because it starts at the minimum. So I have negative 57.5 cosine of pi over 4t plus 62.5. So if you haven't already, pause the video and do exercise 4 and then come back. This question says the possible hours of daylight in a given day is a function of the day of the year. In Poughkeepsie, New York, the minimum hours of daylight occurring on the winter solstice is equal to 9 hours, and the maximum hours of daylight is equal to 15 hours. If the hours of daylight can be modeled by a sinusoidal equation, so a sine or cosine equation, what is the equation's amplitude? So first I'm going to find the midline, which is the average of the max and min. So that's going to give me 12. And then my amplitude is from that 12 up to the max, so that's going to be 3. So it is choice 3 for that one. So on this, since I skipped the graphing calculator piece, if you go to your homework, number 3, part B, you can skip. Okay, everything else should be fine. That's the only part that would require a graphing calculator.